Hello, the purpose of this video is to review variance and standard deviation and show you how to calculate those using the computational formula. So a lot of people are confused by what variance and standard deviation are. So first off, what are they? So variance and standard deviation are measures of variability. That is, they measure how dispersed or spread out scores are in a distribution. Take, for example, the following two distributions. One is an example of scores that have a low variability, and one is an example of scores with high. What we mean by that is here on the left, we see a distribution of scores with a standard deviation of 5. Look how narrow it is. That means all of the scores are clustered around the mean or average score. We compare that to a distribution where the standard deviation is 15, much bigger than 5, and look at how dispersed or wide this curve is. The scores are much more spread out across that distribution. So one sticking point or muddy point for students when they take PSS 302 is trying to calculate variance and standard deviation and understanding the difference between a definitional versus a computational formula. You should always, always, always use the computational formula to solve problems. Computation means you are computing, and they are going to be much easier to do. They're going to save you some math steps, and they may make your job easier. However, sometimes these computational formulas lose their meaning, right? So here's a computational for variance of the population. And so if you're not really thinking about, wow, what do I mean by the sum of x squared divided by the sum of x squared, the definitional formula helps to show you what exactly are we doing. Well, we're measuring the dispersion or how variable these scores are spread out. So what we want to do is actually add up the difference of every single score in the distribution from the mean, and then we square those to get what they call the squared deviation scores. And then we divide it by n. So that mathematically we're thinking like, oh, it's just like we're calculating the mean or the average of these different scores. But let's see what happens if we try to calculate using the definitional formula versus the computational formula. So here is, let's say I have a set of scores where I have 5 participants. Participant here, 1, 2, 3, 4, 5. X is the score that they got on a test. So let's say this participant got a 4, participant 2 got a 10, and so on. Let's just say that the mean of this distribution of scores was 8. Now, to use that definitional formula, I'm going to have to subtract every single score from the mean, and then I'm going to have to square them, and then I'm going to have to add them all up and divide by n. The computational formula, though, even though it looks uglier in the sense of like you have to remember what the EX squared and EX parentheses squared mean, once you remember that, all you really need are the set of scores, and then you calculate the sum of x and then the sum of x squared. So it's much easier to use these computational formulas. Okay, so that's the logic about the difference between the definitional formula and a computational formula. Let's see how it works. How on earth can I use this complicated formula to solve a problem? So here we have the computational formula for the population standard deviation. The symbol for population standard deviation is the Greek letter sigma, and so that looks like a little lowercase o. And the formula is the square root of the sums of squares divided by n. And that's it. That's the whole formula. However, you do need to calculate sums of squares. So sums of squares is this calculation. The sum of x squared minus the sum of x squared divided by n. Let's see how that works. So let's say here again, I have these students, right? And let's say these data points aren't really indicating a score on a test, but let's say these are representing the number of times each student visited the Tutoring and Learning Center in fall semester. So student 1 made 4 visits, student 2 made 10, student 3 made 6 visits, and so on. I want to know what the standard deviation of this set of scores is. Of course, I can calculate the mean, I could do a bunch of things, but in this problem, I want to get the standard deviation. So I remind myself of the formula. All I really need is get that sums of squares divided by n and take the square root of that, but I need to solve for the sums of squares. And that formula is the sum of x squared minus the sum of x squared. So to get the sum of x squared, this first one, you actually have to square each x value and then add it up. And so I'll show you how we're going to do that. To get the n, you just count the number of scores you have, so 5 total scores. And then for the sum of x, you just add up all the scores. So let's see how that works. For n, I have 1, 2, 3, 4, 5 students. Now for the sum of x, I'll give you a second to try to calculate this. You can double check with a calculator or in your head. 4 plus 10 is 14, plus 6 is 20, plus 14 is 34, plus 22 should be 56 if I did that correctly in my head. And again, this is representing the sum of x, so that up here, when I need to do the sum of x in parentheses squared, I square this value. Now the last thing I need to do is get the sum of x squared. So I have to square each of these values. 8, 100, 6 squared is 36, 14 is 196, 22 is 484. I add up all those values and I get 824. So now all I need to do is plug in these values into the formula. The sum of x squared, I am going to have to calculate the sum of x squared, so I have to square 56 at some point and use this 824 for this sum of x squared value, and n equals 5. So let's see how that works out. So a refresher on the actual numbers that we have. N is 5, sum of x is 56, sum of x squared is 824. Let's solve for sums of squares. And this is how I want to see your homework assignments, by the way. Include the full formula at the beginning so I know what formula you're using, and then actually carry it out. I know it's a little bit tricky in Word, but if you need help with that, just let me know. Okay, so sums of squares, then plugging in the numbers. 824 minus 56 squared divided by 5. And I can carry out those values. I got the square of 56 was 3136 divided by 5. That was 824 minus 6, 27.2. And my sums of squares value is 196.8. Yay! I'm almost done. Now to solve for standard deviation, though, I need to get the standard, the sums of squares divided by n and take the square root of that. So I plug in the numbers I just calculated. 196.8 divided by 5. I carry out that math. I get 39.36, and I take the square root of that. And voila, my standard deviation of this distribution of scores is 6.27. All right, I hope you found that video helpful for refreshing your memory. So I hope you found that video helpful, but if you have any questions, just let me or your professor know.